Welcome back. This is video 10 in the series, and we're going to discuss understanding mineralogy when designing regrind and cleaner circuits. The regrind circuit feed is the rougher concentrate which contains high proportions of sulfide minerals and low percentages of non-sulfide gangue. The majority of the non-sulfide gangue has arrived in the rougher concentrate as either coarse, value-deficient composites or as fine, probably less than 30 microns, liberated particles that are recovered by entrainment in the water phase. The first piece of mineralogical data required for this part of the circuit is the target grind size to liberate the valuable sulfide from the sulfide gangue. For example, looking at liberating chalcopyrite from pyrite. Again, completing a liberation study will show how the minerals are locked together on a size basis, and from this we can work out what size we need to grind to achieve at least 80% liberation of the valuable mineral from the gangue. The modal analysis also tells us something about wear. Typically, regrind feeds tend to have high sulfide mineral content, which means that the dominant wear mechanism is corrosion. Ideally, to inhibit grinding media corrosion in regrind mills, high chrome or ceramic media should be used. The high sulfide content of regrind feeds, particularly high pyrite grades, will generally produce pulps that are very reactive, which will dominate the pulp and surface chemistry. An understanding of the mineralogy of the regrind feed will provide very good indications of the chemistry of the pulp leaving the regrind mill, and how this will affect flotation behaviour in the first and subsequent cleaner flotation stages. That is, a high pyrite feed will invariably lead to a pulp devoid of oxygen leaving the regrind mill, and these conditions are ideal for pyrite flotation, resulting in low concentrate grades and recoveries. The mineralogy also gives us an indication of the ability to produce a saleable concentrate, and from this, the potential profitability of the process. The mineralogy will also provide information about the deportment of penalty elements, for example, arsenic, antimony, mercury, bismuth, and others. A good understanding of where the penalty elements are, for example, associated with the sulfide gangue, like arsenopyrite in pyrite, or in solid solution in the valuable minerals, for example, antimony in galena, will give the metallurgist clues on how best to remove these species from the concentrate. If you'd like more information, please make a comment below.